going to learn. The topic is especially electric power, right? So actually, in mechanics, the power meaning, just their power we used as capacity. Right? Capacity is what? Energy by time, the rate of energy utilized or used by a person to do something work. Energy is what? Nothing but the rate, the amount of work done simply. The ability of doing work is called as energy. So in terms of electricity, that capacity of electric component is expressed in terms of power, right? So power is equals to the rate of energy used by the component, E by T. So here energy is calculated in terms of work, right? The ability of doing work is called as energy, right? So now you can write the power formula is equal to W by T. So what is this actually, energy or work here? Energy or work. So that energy or work we are using for what purpose? Especially to move the charges, from one end to the other end of the conductor. Suppose there is a charge Q, So using certain amount of force, you are trying to move that charge from one end to the other end. So who does that work? That work done by potential difference. So just you need to create a potential difference between the terminals of the wire to complete this task, right? So automatically what happens with the potential difference? It will take certain time to reach from one end to the other end, right? So within that time, automatically the charge is forced to move towards other end of the terminal. So it depends on the type of charge. If it is positive charge, in the direction of field. If it is negative charge, opposite in the direction of field, right? So in the direction of the field or opposite in the direction of field will be decided by the type of charge, right? So here potential difference is created between the ends of this wire between A and B. So due to that potential difference, the amount of charge Q is passing through a conductor in the electric field direction. That means it is taken as positive charge, right? So here Fe is applied. The charge is passing through a conductor, right? So here what happens when the charge is passing through the conductor? Actually, that material has certain nature. That nature is what? Obstructing nature, called as resistance, right? So here the charge is moving through any cross section. You can define that as amount of current. So we have resistance and we have current. So due to this resistance, what happens? Automatically certain amount of heat energy generated in this wire, right? So now we are considering that amount of charge Q as Q coulombs passes through from point A to point B here, right? So point A to point B here. So in this, suppose if you are connected or created that potential difference something V between A and B, right? So the work you are calculating using the potential difference. So potential difference formula already we know, V is equal to W by Q. So what amount of work done on the amount of charge? If it is unit charge, we can take it as small q. If it is net charge, on that net charge, what amount of work you are doing, that we are taking as V equal to W by Q. So from this, I am able to find out the work done. So here transposing V into Q, we are able to write. So W is the work done on unit charge to move it from one end to the other end, right? So E is given as, right? Here, simply the product of voltage and charge, the product of voltage and charge, right? So that we can take it here, So W equal to, already I know W is equals to, by using this W, I am able to find out the power. So power is equal to what? P is equals to W by T. So here, simply, I want T here. So what I can do, I'll write, but right side, it is a balanced equation, will not accept me. So on both sides, I am dividing this equation by T. So now it will be balanced equation. So T gets cancelled, again it remains as W equal to V into Q, no difference, right? So I got the same thing. Then here what I am doing, I know left side, what is W by Q here? Sorry, W by T here. What is W by T here? So W by T is rate of work done, called as energy, or the work in unit time, nothing but energy, right? So here it is taken as, right? It is taken as here power. W by T is nothing but power. So that power of P is equals to what I got, V into Q by T, right? So here V into Q by T, just I am considering Q by T here. So what I know, Q by T is equals to I is equals to Q by T, I know. I equal to Q by T. So that Q by T will be replaced now here. So V into I. What I got? P is equals to V into I got. So P equal to V into I. This is defined as power. The product of voltage and the current. The product of voltage and the current is defined as power, electric power. Okay. So here, if you use Ohm's law here, V is equals to IR. So I am able to replace V using I and R. So P is equals to V into I. So I into R into I. So here it is nothing but P. That equal to I into I square R. So P is equals to I square R. If you replace here in this I, so one more formula you are able to get. So from the Ohm's law, I written I is equals to V by R. So in a power formula, P equal to V into I. Now I am replacing I value, that is V by R from the Ohm's law. Then V into V, V square by R. This you are able to get. Right? So like this, we can replace the formulas. Like this, we can replace the formulas. Right? Suppose if it is in case of a dry cell, that P is taken as EMF. P is taken as EMF. So P equal to E, that is equals to V into I. So E is the EMF here. Right? Sorry. V is replaced by E here. So P is equals to E into I, we can write. So power is taken as product of EMF and current. Right? So here simply P equal to V into I or P equal to E into I. This we can take it as the formula for calculating the power. So I got what is power and its equation. Then what are the units of power? Right? So here power P is equals to W by T actually. Power P equal to what? W by T. So W is work or energy measured in joules, and the time is measured in seconds. So joule per second. The joule per second is named as watt. Right? Scientist name. James Prescott. Here is watt, right? So joule per second is named as watt. So watts are the units of power. Watts are the units of power. So power is nothing, the rate of energy flowing through it or consumption, right? The rate of energy flowing or consumption through any component is defined as power. Are you clear about this one? Power. Is it okay? Any confusion is there? No. Right? So we got the idea about the power. Then here, power units are given as watts. Power units are given as watts. So here that watts are smaller units actually, right? That watts are smaller units. So that small unit we can convert into kilowatts. So we know 1 watt is equals to 1 joule per 1 second. 1 joule per 1 second. So here on either sides, I am multiplying that by 1000 into 1 watt is equal to 1000 into 1 joule per second. Is there any change? So either sides again 1000 cancel means remains same as 1 watt equal to 1 joule per 1 second. So no change. So here LHS side this 1000 I am writing as kilo. Then 1 watt will be written as W. So 1 kilowatt is equal to 1000 joule per second. No change in this. Then here again I am transposing this as follow here. 1 kilowatt is equal to what I got 1000 joule per second. So either sides I am multiplying by hour, right? 1 hour. So into H hour, 1 hour. So 1 kilowatt hour is equal to 1 kilowatt hour is equal to 1000 joule per second into 1 hour. This 1 hour I am replacing as here number of minutes into number of seconds per each minute. So that I got 60 into 60. That means what? 3600 seconds here. 1 hour replaced as 3600 seconds. Now here you are able to cancel these units, second and second. Then what is remained as here? The remaining is 1000 into 3600, right? So how many zeros are there? 1, 2, 3, 4, 5. So 5 zeros. 36 into 5 zeros written as 10 power 5 joules. That equal to, again I am converting this into decimal form. That is here 3.6 into 10. So 10 into 10 power 5 will be written as 10 power 6 joules. So what I got? 1 kilowatt hour is equal to, I got 3.6 into 10 power of 6 joules. So here this 1 kilowatt hour is named as 1 unit. So 1 unit is equal to 3.6 into 10 power of 6 joules. This you need to remember. Which is considered as 1 unit? 1 kilowatt hour. So 1 kilowatt hour named as 1 unit. 1 unit is equal to the energy 3.6 into 10 power of 6 joules. If you consume 3.6 joules, 3.6 into 10 power of 6 joules, then it is considered to be 1 unit. There is no fixed time to consumption of this energy. To consume this energy, there is no fixed time boundary. If you are consuming that energy, maybe in 1 second, or maybe in half an hour, or maybe in 1 hour, or maybe in 1 day also, by slower rate, right? So it depends on the appliance's capacity, its power, that rate of consuming the energy, that is only its power, right? So where you can find out power? Actually, the rate of work done, right? The rate of work done. So who is working for you? electrical appliances by using what? Energy. So that we can express in terms of power. For example, for any appliance, you may given by something watts. For example, here daily using bulb, it may be 10 watts, 25 watts, etc. So what does it mean actually? That watts are given on the bulb or something, right? So what it refers to you? What? It gives you information. So 10 watts and the voltage may be given as 120 or 240 voltage, 220 voltage, like that. So what does it mean? Suppose here as example 60 watts and 120 volts are given. So here if you create the potential difference 120 volts, then it gives you idea about 60 joules of electrical energy converted into heat or light in a second, right? So here simply you are able to find out its power. So power P is, power only given as 60 watts. What is what here? 60 joule per second. What is replaced as joule per second? So what does it mean? It can use 60 joules of energy in a second. 60 joules of energy in a second. So here by using this, you are able to find out its resistance, right? So here I know its power and the potential difference also given as 120 volts here. Then I am going to calculate here its resistance. So using the formula power is equal to V square by R. From this R equal to V square by P. What is V? Here V is given as here. V is given as here 120 square, 120 into 120 by P. P is given as 60. So R is equal to 120 into 120 by 60. That equal to cancellation 0, 0, 6 1 ja, 6 2 ja, 122 times 240. So 240 ohms is the resistance of the given bulb, right? So this you need to understand, right? This you need to understand. So if the bulb is connected to the 12-volt battery, then the consumption of the bulb given by, right? So power you are able to calculate by knowing the resistance and the potential difference. V is equals to 12 volts is given. So now the power equal to V square by R. So what is V value? 120, 12. 12 into 12 by R is 240. Resistance I got 240. So here 12 1 ja, 12 2 ja. So 20 is remained. Then 2 1 ja, 2 6 ja. Then I got 6 by 10. That equal to 0.6 watts. Right. So depending on the potential difference, it's power, the rate of consumption of energy changing, right? The rate of consumption of energy changing depending on the potential difference that we observed here, right? Are you clear about this one? How to calculate that power, or maybe the resistance, or maybe the current? You are able to find out the current also, because already you got what resistance value is 240, power is something 60 watts, then potential difference is equal to 120 volts is given in the first case, right? Then what about the current? So using the formula, power P is equal to I square R, right? Or you are able to get P equal to V into I formula using, then V is equals to IR, replacing here IR into I, that equal to I square R. This is the formula I am written here. So I square, I want to find out I value. So I square is one side, then remaining are opposite side, P by R. So what is P here? 120. What is R here? 240. So what you will get? This one. So 1 by 2 here. That is I square equal to. Then I is equals to 1 by root 2. That 1 by root 2 value already you calculated in 9th class. Root 2 value is 1.414 and 1 by root 2 value is 0. Something 41 something is that. So 0.4 amperes it will allow the current. Right? So like this we can calculate anything by knowing the power. So is it clear to you? Just give me your quick impression. Is it okay? So you got an idea? Yes. Right. So I got the meaning of 1 kilowatt hour is 1 unit. Right. Then I know how to calculate. It's a resistance or current by knowing the power and the voltage. Right. So that completed. Now we are having the discussion about overload. So what is the meaning of this overload actually? Right. So here, is there any damage created by this? Right. It causes the damage to any electric appliance or there is no effect. That you need to understand. So here, overload is what? Taking more burden than its limit, beyond the limit. If it is working beyond its limit, what happens? That is only taken as extra burden called overload here. So simply that overload of current gives you damage to the electrical appliances, causes damage to the electrical appliances. So how it can be? Right? So that we can see here simply by using the simple electric circuit diagrams which are given at your home. Right? So here electricity enters into your house, right, from the poles using a main wire that which has 2 terminals. So any other wire is used other than this one to receive the current? No. So that current is allowed through the wire into your main power supply, right? That we are given at home, right? That is here simply main, right? That main is receiving current here from the electric pole using a single wire, right? Then after receiving that current from the electric pole, simply what we are doing here, that many connections we made from a junction. So from there you are giving different connections, right, into the different rooms of your house. Then in that room also you are using many switches to operate many appliances like bulb, fan, AC, refrigerator, right, grinder, electric heater, etc., right? So here they are operated by the single switch or many switches. So here many switches. Why we use? To make them to close or open circuits. To make them as close or open circuits. So here you are using, right, switches, multiple switches. That will give you idea about multiple circuits are there in household connections. In household connections, multiple connections are given. That means you are making multiple circuits which do not depend on the other circuit. Independently they can work. That means what? They are in a parallel combination. How they are connected? In a parallel combination. So household connections are what? Parallel circuits. How you are connecting them? In parallel combination. So here simply there at your box, you are now able to apply junction law. What it is here? Sum of the currents reaching the junction will be equal to sum of the currents leaving the junction. So only one current is allowed, that not one unit, only through one wire you are receiving the current and you are allowing that to pass in many paths. So what the junction law says, sum of the currents reaching the junction is equal to sum of the currents leaving the junction. So I is equals to I1 plus I2 plus I3. Okay, here up to here there is no problem. We are able to explain it clearly. Then the main important point here is simply what amount of current allowed through this wire. What amount of current is allowed through this wire, right? So here the domestic appliances are here, wires or the meter. It maximum allows you 5 to 20 amperes of current, and the maximum voltage you may reach here 240, right? So the maximum amount of current is allowed 20 amperes. The maximum potential difference is created 240 volts, right? So that we read on the meter. So just observe your electrical meter display. So on it you are able to find out this information, right? What is 5 amperes to 20 amperes, and the potential difference is 240. The potential difference is 240. So that information you are able to read on your meter display. Right? So here maybe digital meters or analog meters, whatever it may be, right? Then on them you got this information. So maximum amount of current is 20 amperes. We know the power of appliances, right? For example, bulbs are there, each one 100 watts or 10 watts. Suppose 10 watts you can take, right? So what amount of current it can take, that you are able to calculate by using the formula P equal to I square R. From this, I is equals to under root P by R, right? So use this formula and calculate the amount of current allowed through the appliance, right? So this will help you to calculate the currents. So individually you can calculate the currents I1, I2, I3, I4 through different appliances. Right? Will they receive same amount of current or different? We discussed already in a parallel combination. In the parallel combination, voltage is constant and current divides, right? So it made into many parts depending on the resistance. That means appliances, right? So current divides. Then you can verify I is equals to I1 plus I2 plus I3 plus dash dash dash. It is as per your junction law. As per junction law. So that a junction law says some of the currents reaching and some of the current leaving are equal. So that already we know. So here look at one circuit diagram is given here in the page number. It is page number 202 or figure number 32. So here look at that amount of current passing through individual appliances are given. So TV 6 amperes, fridge 8 amperes, bulb 2 amperes, fan 4 amperes. Just it is assumption, right? Then see the amount of current utilized by them. 4 plus 2 plus 8 plus 6. That is already 20 amperes. So what amount the maximum current is allowed? That is 20 amperes. What happens when I switch on this heater? So when it is connected, this also will be allowed with certain amount of current. So what amount of current? It may be unknown value, but that amount of current here will be added, right? The amount of current will be added here. So 20 plus I amperes, right? 20 plus I amperes. But your electrical conductors are designed to where the maximum amount of current is 20 amperes. Now you are trying to get more energy. You are trying to pull the energy from the junction. So what happens here? Your wire is manufactured with certain amount of specific resistivity and it is designed for certain value of conductivity. But you are trying to draw the current maximum more than your limit. So what happens? It gets overheated, right? It gets overheated, so that heat will melt the wire, or if it is unable to melt, what happens? It gets heated. So at the weak zone of your wire, it starts burning. It starts burning. So that burning may create fire, right? So the fire may be produced at a weak zone or fault zone. So automatically what happens? It give you simply short circuit, fire producer, right? So this is we need to understand. Then here, how to protect? Because always I am not able to calculate these values, what amount of current it is drawing, right? I need to verify because it may be causes the damage to the. It is very risky process, right? Simply we are ready to operate that circuit only by the switch, but there is damage to the electrical appliances. So how to overcome? Using a fuse, a safety device, right? So that fuse we will discuss in the next meeting. Join immediately. Time completed.